Okay, can somebody help me with my priority list so far? Bottom of the totem pole so far.
We have alkyl halides,
Okay.
and then we have alkanes. Then
I don't go
ethers.
alkene, and no, I don't know. Alkene,
Yeah,
the YNE and then the ENE.
yeah.
Okay. At the bottom,
Yeah.
and there's no other ones since we've talked about
And
alcohols. We've
amine,
talked
and
about,
then alcohol after those.
what was that? Who do we have after that?
Oh, wait,
It's
yeah.
alkyne, alkene, then amines, and then alcohols.
Now remember, it's been changing because you've been introduced to new ones, right?
Just those.
That's all we have on our list so far.
Yeah.
We have the halides and the ethers too.
Okay. No amines. I didn't give you amines. Where amines lied. I didn't tell you about alcohols.
Yeah, amine is after. Yeah.
Okay. Amine. Oops.
Mom. Hey, Mom. I'm maybe upstairs watching YouTube.
Two. Okay. Okay, how you feeling so far? Those are the ones? Did I forget anybody?
That was it.
That was it. Okay, so let's add these three guys. Okay. So we have ketones. We have aldehydes. And at the top is going to be carboxylic acid. Okay. And carboxylic acids are at the very top. There's some other ones that we're not going to talk about right now. I'm going to save those for when you actually go to. These should give you enough to sit there and do some nomenclature and with things that we're going to be working with. Okay. So let's talk about the ketone. The generic form of the ketone is the generic form of the aldehyde is the generic form of the carboxylic acid is okay. So what do all of these guys have in common?
The oxygen?
Kind of their shape.
The oxygen, what's happening with the oxygen? The oxygen is bonded to whom and what type of bond is it?
Double bond.
It's double bond.
Double bonded to what?
To the R.
Okay, to the R, it's double bonded to the R. What is this? What would that be?
Would it be?
Or does that mean it's double bonded to the combination of them?
No, it means it's double bonded to the carbon R means any hydrocarbon. This R means any hydrocarbon. This
Yeah.
means this is a double bond and this is understood to be a C, right?
Yeah.
So it's,
I need to find it.
so you remember at every N, if there's not a letter there, what is there? What are these, guys?
Carb.
There's a carbon.
Each of these, each point is a carbon, right?
Yep.
What is this? Or
A double bond.
of what?
Of carbon?
Carbon.
So if you just see this, you know it's double bonded to carbons. It's understood to be a carbon, right? So remember, this here is your skeletal structure. It's a carbon skeletal structure. It's understood to be carbon, okay?
Okay.
Okay, so don't forget that, that's essential. So that means that we have an O double bonded to
2 carbons.
a
The
carbon. Yeah, to a carbon. Okay, so in this case, on one side, we just have a hydrogen, right? That makes it an aldehyde. Now, that means that the name, if the aldehyde is the highest functional group, the name will end with AL. So let me give you an example. Okay, so let's count the carbons. 1, 2, 3, 4. So what is a 4-carbon chain called? What is that prefix?
Is it tetra?
Nope.
Is it bute?
Yep. So that's the thing about organic chemistry. It doesn't use only Greek prefixes. There's also other prefixes that use it. So we don't want to mistake our Greek prefixes for our organic chemistry prefixes. Okay, so it's bute. So it would be bute. Since are these any double bonds except for this one here in this chain?
No.
Nope. So then it's ane, and then we'd put al. Okay, so this guy would be 1-butanal or just butanal, because this guy's a terminal. It always ends at the end. It's a terminal functional group. Okay. So what about this guy? What would this guy be called? Okay, what is the carbon chain? How long is it?
It's octane.
Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So what would we call this guy?
Octanol.
Octanol. Not all, because it's not an alcohol.
Octanol. Yes.
Octanol. Oops. Okay, simple.
Yeah.
Yeah.
What was that?
Yes.
Okay, what about this guy? Hasn't had your coffee this morning. So what is the longest chain? Olga.
5.
7.
Oh, no, 6. Because that one connects is already the H, right?
1, 2. Yeah, this is the H. So that's 2. This is 3. This is 4. This is 5. This is 6. Okay. This is a side chain, right?
Mhm.
Yeah.
Yes.
Okay. So how will we name this guy?
Methane.
Heck?
Or wait, the little one is methane.
Is it methane or
Methyl.
methyl?
5.
So
Methyl. Methyl, that's right.
So it'd be 5-methyl.
6. 5-methyl hexanal.
5-methyl hexanal.
Okay.
Piece of cake?
Yeah.
Okay, so again, these are all aldehydes. Aldehydes get that Al. Al.
Okay.
Okay. Okay, are we cool on the aldehydes? I'll leave these up,
I think so.
but I'll erase this one. I'll move the other one over. Okay, what about, let's see, ketones. So the way ketones work is okay, so you count the longest chain you can get. And then also you want to get to the shortest distance to the double bond. So this is 1, 2, 3, 4. Or if we go this way, it'd have been 1, 2, 3, 4, 5, 6. So which one is shorter distance? 4 or 6?
4.
4.
Okay, so this is the distance that we're choosing to go. We're going in this direction. So then we give it the name of the longest carbon. So that prefix is what?
Non.
Are there any double bonds?
Yes.
Other than the one that's attached to the,
No.
No.
so in the carbon chains, there are no double bonds down here except for the one that's attached to the O. Okay, so then we put ane, and then we put ONE.
Non-anone.
And then we tell where it's at. Where's that double bond?
At 4.
So it's 4, no, name, known. Okay?
Sounds like a tongue twister.
It is. It's a little bit. What about this guy?
Two pentanone.
Four.
Okay? What if I have this?
See, I think 2-hexenone, but I wouldn't know where to put the number of where the double bond goes.
Okay, so let's do the counting. Oops. So this is the one where you'd have to actually, let's go, hex. Or you could write it this way. Oops. Yes, no. You'd have to keep it that way. Yeah, it would have to be written that way. Okay. Questions, concerns, cash, credit.
None of the
Okay.
above.
So how do you distinguish between a butan, let's say a butanal and a butanone? What is the distinguishing feature?
The butanal has hydrogen.
Okay. So we have a hydrogen at the terminal end. The butanone is going to have, it's going to be a carbon chain. Okay. Questions, concerns, cash, credit?
Why is it Ian right here in between the 3 and the 2?
Why is it an EN?
Yeah.
Because it's a double bond, right? Where's the double bond located at?
At the 3.
At the 3. So EN reminds me it's a double bond. EN, double bond, right?
Oh, that's right. Yeah.
Okay. Oops. Okay, so we have, drag this over here. Okay, so we have next a carboxylic acid. Okay, in this case, we're still going to do our numbering. That's going to be our first carbon. That prefix right there for 3 carbons is what?
Is it prop?
It's prop. Okay, so are they double bond or single bond?
All single bond.
All single bond. Okay. And then we put oic acid. Propanoic acid. Simple?
Yeah.
Okay. What would this guy be called? Let's see. Ariana.
Isn't there 6, right?
So let's count. See if I can get that pen working. So that's 1, 2, 3, 4, 5, 6. Okay. So 6. So what is a 6th carbon?
I don't remember the name.
It's hex, Ariana.
So it's hex. Now you want to know this by next week, right? Because you know this is going to be in the exam, right?
Yeah.
Okay, good. So hex. So is there any double bonds? No double bonds. Okay. And then what do we put at the end?
IOC, right?
Yep,
Then acid.
that's right. Hexanoic acid. Simple?
Yes.
Okay. So you want to try one that's a little more challenging?
Mm.
It's going to have a double bond in it, isn't it? Either that or a triple bond.
It's worse.
Okay. Are we ready? Let's see. Aubrey,
Yes.
Okay, what is the longest chain?
7.
Are you sure?
Oh,
4.
8.
Okay, so 8 is our longest chain. So that's going to be our main chain right there. Main chain. Okay, so the back part is going to be called what?
Oct.
Oct. Are there any double bonds?
Just the one for the O.
Okay, so then I'm just going to use A. Okay, are there, and then the ending should be?
IOC. Acid.
Okay, and then this side chain, how many carbons?
There's 2.
Okay, so then that would be
5 ethyl.
5-ethyl octanoic acid. Piece of cake? Yeah, nope, maybe?
Yeah.
Okay,
Sort of, perhaps.
yep, soda perhaps. Okay, so these are the ones that I want you guys to be familiar with. Okay. And then I'm just going to throw one more thing up. So you want to be able to identify the functional groups. So is it a ketone? Is it an acid? I mean, is it an aldehyde? Is it an ether? Is it a carboxylic acid? Right? And you should be able to name the simple structures. Now, there might be some complicated structures that you may get extra credit for. Okay? But at least be able to name the simple structures. Okay, let's see. Let's do this. I want to show you one more thing, and then we're going to move on to another topic. Well, we'll do a test run, and then we'll move on to another. Make some room. Everybody got everything down so I can clear up a little bit of space?
Yep.
Proteins are made up of what?
Amino acids.
Amino acids.
Amino acids. Yes, I was thinking lipids, but I'm like, wait, no, that's fats.
So what functional group is this guy?
I can hardly tell what I'm looking at.
Is it amine, Dr. Henry?
That's right. It is an amine. And then what functional group is this guy?
An aldehyde.
Mm-hmm.
An aldehyde? Are you sure?
Carbonic acid.
Oh, wait, never mind.
Carboxylic acid. Carbonic acid is a different type of acid. I'll show you that later on. Prompts.
Gosh, who came up with these names?
Okay, so together, amine, carboxylic acid, we get the name.
Oh, amino acid.
Okay, so that's what an amino acid is, right? So this is the functional group for amino acids. How many amino acids are in the human body? Or I should say, there's actually more than what we actually use for protein. How many are in protein structures? How many different amino acids?
Is it 12?
Not 12. Go up a little higher. Well, not a little higher. Go up higher. That 2 component of it that you have in there is right. So
23?
not 23. Go down lower.
20.
Even number. What was that?
20.
20, yes. There's 20 amino acids. So if you guys are taking micro, or you're going to be taking some form of biology here in the next, you're going to probably need to know your 20 amino acids. Okay. So, but that's the general structure. And where R, again, is going to be a functional group, usually a hydrocarbon. Okay. Questions, concerns? Cash. So how many different functional groups should you be aware of? For organic chemistry? Mandy? Mandy, you're there. Or as I say, families. Damn it.
Mandy, I'm here.
Here? Okay, Mandy. How many different functional groups should I be aware of?
A lot.
A lot is not an answer. I want a numerical answer.
10.
Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you should be able to identify 10 different functional groups.
Mm-hmm.
Okay. Now, the best part is there's a whole bunch more, but you only have to identify 10. You got that, Cassidy? Yeah, no, maybe. Cassidy, are you there? Oops.
She chatted.
Put it in the chat, yeah.
Okay, so let's see those skills. We're gonna see what you guys can do here. I'm gonna give you a couple of structures. I'm gonna throw you in the room for about 10 minutes, and then you guys are gonna come back out and give me some other, give me the answers, right? Okay, you guys are gonna do A for me?
Yeah.
Okay, Aubrey, Diego, can you guys handle B?
Yeah.
Erica, Giselle, Mandy, and Roman, can you guys handle C? And Azucena, Cassidy, Damaris, and Oscar, can you guys handle D? Then we'll compare answers. Okay, so let's go with the A. Everybody has their name up. Okay. Let's see, we have I have 2. Somebody has 2-dimethyl 5-ethyl 4-methyl, no name. You guys agree with that or do you disagree with that? Anybody there? Can you guys hear me? Knock, knock.
I think they went kind of backwards. Like they should have started with the one at the left instead of at the right.
Oh, so you don't agree with where they started from?
I thought it was we start where it was closer to the chains, no?
That is correct.
You want
wanna
the
get
lowest number.
the lowest number, and that would be the lowest number. So they're correct in terms of where they started from. Okay. Now the name though, tell me something. I don't know, but maybe I'm old or something. And I could be, I'll admit.
Wouldn't ethyl go first?
Okay, your ethyl's gonna go first. Okay, so that's one thing. And this is a methyl, is that right? And this is a methyl, that's right. And this is a methyl. So how many methyls do I have?
3. See, we weren't
Trimethyl.
sure if we could group them up or not. We were like, do we split them up or?
Nope, you group them up. And so you call it trimethyl. And it would be, you have to tell me where all of them are located at. You have 2. I'm gonna correct. You
2,
mind if
4.
I correct your answer? You won't be offended, Olga? So
No,
you'll have
it's a
2,
learning
2.
experience.
And where is it? 4? 4 dimethyl, or so it's trimethyl now. So this is where you use those Greek prefixes. So trimethyl. Five ethyl, 2, 2, 4, trimethyl, no name. But that was a good attempt though. You guys, do you see the difference?
Yeah.
Yeah.
Okay. K. B. So how do you guys feel about B? You guys feeling good about B? Yeah, no, maybe.
don't
Anybody
know.
not feeling good about B?
It's great. Perfect just the way it is.
Perfect just the way it is. Are you sure?
I thought it was
No,
No,
I
wait.
am not sure, but I'm just saying that because that's the one that
Yeah,
my group was assigned to.
what
Oh, so-
Mandy said, pentanoic.
Pentanoic, yeah. So I'm gonna correct yours real quick. I'm gonna put the dye in there since you're right, it is that dye. I saw you have to do that independently. And you don't need to put this dash here. And then you want pentanoic. Otherwise, it's good. Okay.
Okay.
And there's no attempt on okay, so let's start with the numbering of the chain. How will we number this chain?
It'd be 1, 2, 3, right?
Okay, so the main chain is going to be 3. So we have, somebody had already started, which is 1, 2, and then you could say 3. Either of these could be 3. It doesn't matter. So we could say this guy is 3. Okay. So the side chains, these guys are side chains, right?
So 2-dimethyl.
So we have 2,2-dimethyl, because you have to account for both locations.
propanol.
Propanol.
Yeah.
Okay, good job. Okay, D. Yeah, it is an alkene, but let's name it. Oh, Oscar threw it up there. So where does the double bond start? You always want to go with the smallest number as your starting number. So where does it start at?
The left.
The left, but what carbon does it start at?
2. 2? No, 1?
Is that the one, Dr. Henry?
Starts up at the 1.
Mm.
Okay, so we have 1, 2, 3, 4, 5. So then that means we have, we said 3, 4. Yep, that's good. Okay. So who's gonna be, we'll start off with group 4. You guys are gonna do E. Group 5, you guys are gonna do F. Group 6, group 5. Let's see. Oscar's group, E. F is gonna be Erica's group. G is going to be Joanna's group. And H is going to be Whitney's group. And Cole is going to do I for us. Right, Cole?
Sure. Okay.
Now remember, you want to count the longest carbon chain. Give me my hint. You want to count the longest carbon chain.
Is that for me, Dr. Henry?
I'm just saying.
Let's see. Oh, yeah.
Is someone doing F? Because that's one I know.
I believe that is your group, Mandy.
Oh, I guess I can do that.
So Melissa, Joanna, Diego, Aubrey, you guys have G. You guys are you working on that?
I'm kind of lost, to be honest.
Lost.
I mean, lost, like I kind of forgot how to do this one.
Melissa, you gonna help him? So what do we always start off with? What is our very first part of the rule is to do what?
Find your longest chain.
Find your longest chain.
That's 6.
Okay. So the root is going to be what? Are there any double bonds in that long chain?
No.
Okay. Is it okay? So then a 6 carbon chain is called what?
Hexane.
Okay. So the last part is going to have hexane in it, right?
Right.
Okay. If I have
It's the
a,
bromine part.
so what do
but,
we do with the bromine part?
Well,
If
it's at
chloride,
2.
chloride, or bromide, or iodide, we put a what at the end of it?
No.
Bromide.
Bromo.
Bromo. And you just tell me where it's at. And then it's all alphabetical
At
order,
2.
right? So it'll be 2-bromo.
2 bromide.
No,
And
not
then-
bromide, 2-bromo.
Bromide. 2 bromo, and then 3,4 dimethyl
That's right.
or dimethyl hexane.
Okay. You got that, Melissa? Look at her. She's just on top of it. Okay, let me fix your little typo. I do it all the time too. Some of my keys are starting to stick because of the experiments that we've done recently. The Mentos experiment.
Mine was out in the dirt, so that dried up pretty quick.
Mine attracted a mass load of red ants.
Did they really?
I got B's.
You got B's?
Yeah.
Red ants.
And remember, it's comma. Put your dash.
I noticed no difference because there's already an ungodly amount of bugs out here.
Okay, questions, concerns, Cash.
None of the above.
None of the above. Oh, you guys are gonna be stingy. Okay, so we have a few more things to go over. A little bit longer than I anticipated. We're gonna use these 4 minutes the best possible way. So we've been talking about ionic compounds, right? You guys know what an ionic compound is. You know how to sit there and determine the charge on certain ions. Okay, so like group 1 metals are going to have what type of ion form? Who's a group 1 metal?
Positive.
Positive what?
+1.
It's going to be a
+1.
+1, right? So give me an example of a group 1 metal.
Sodium.
Potassium.
Sodium and potassium. Now, I'm just going to do a refresher, right? Because I know that you guys know this already, right? And I'm just beating a dead horse. But why does sodium become a +1?
Because it's easier to lose 1 than gain 7.
Okay. And that's its goal, to be like whom?
Noble gas.
And yeah.
A noble gas, right? So it wants to be like a noble gas, so it's going to lose that 1 electron, right? So what about a group 2 metal like magnesium?
2+.
And why is it 2+?
It needs to lose 2.
Because it needs to lose 2 electrons in order
That's
to
right,
be
Mandy.
a noble
It needs to
gas.
lose 2, right? It needs to lose 2 to be like that noble gas, right? So that's the reason why it does it, right? So when we're talking about ionic compounds, we have to take that in consideration. Let's say we're talking about fluoride. So we have fluoride and magnesium. They're hanging out together. So magnesium is going to do what? Magnesium is going to lose its 2 electrons. Fluoride is going to want to do what?
Get an electron.
It's going to want to get an electron. So if it gets a single electron, it has a minus charge. So how many fluorides will I need to balance out magnesium?
2.
2.
2. So then I would write my chemical compound as Mg, and we put 2 as our subscript to let me know that the fluoride we have 2 fluorides to balance out that 1, it's understood to be a 1, magnesium. Are you with me?
Yes.
Okay, so let's say we have calcium and nitrogen. Okay, so what ion is calcium going to form?
+2.
Okay. And what about nitride or nitrogen?
-3.
Okay, so how many nitrogens am I going to need to balance out the calcium? So we have a total of a 0 charge.
2 nitrogen and 3 calcium.
I'm going to need
Yeah.
2 nitrogens and you said 3 calciums. Okay, so then we're going to write this as
And what is this called again?
this is nomenclature.
Okay.
Well, I was just about to ask how it's spelled. Read my mind.
Now, how we go about naming this, because we know what the charges of calcium is going to be all the time, and we know what the charges of nitrogen are going to be all the time, we don't have to tell how many there are. So we just call this guy calcium nitride. We, instead of saying nitrogen, we drop the ogen and put "ide." The "ide" lets me know that it's negatively charged and it's the end of the compound. And the way you always write it, you always want to put your plus charge first and then your minus charge. If you do it the other way, it's wrong. Okay, now what would we call this guy?
Magnesium fluoride.
Okay, so we'll do one more and then we'll have to stop. Let's see. Let's do oxygen and lithium. Okay, so these guys were hanging out. What are going to be the ions formed?
Lithium is +1. Oxygen is -2.
Okay, so then the chemical compound would be
2 lithium.
okay. So then we'd write it down as a
Lithium subscript 2. Oxygen.
okay, and we would call this guy
Lithium oxide.
piece of cake.
Yep.
Okay. Okay, so we got to stop here.